Hello class, this is Mr. Lehman. I want to talk to you about percent error analysis in part 5, and then we'll go on converting from mass to moles, part 6 of our package. So right now you should be in part 5, which is the second page. We're looking at question 10. Anytime we do percent error, it's because there's a number that a lab group should have produced. There's a number that, for our silver lab, there's a number of grams of silver that you should have produced. And so because of improper lab procedures or just improper measurements or carelessness, or maybe just the crudeness of the devices that we're using, we're not going to produce usually the amount that we should perfectly. So sometimes we have too little, and sometimes we have too much. So there's an equation, and I'm sort of dumbing it down here so that you can follow along, to produce and calculate how much error there was in our lab performance. So you can take your value, whatever your lab group produced, subtract it from the actual value. This is what scientists, this is what Mr. Lehman, say that the true value should be. That's what you should have received or produced in the lab. Divide that again by the true value, the actual value, the scientific value. We don't care whether it's a positive or negative number, so we're doing the absolute value. We're getting rid of any numbers that are negative, any negative signs I should say, and then we're multiplying it by 100 to convert to percent. So if we read our question now and use this formula, it says your lab group produced 0.85 grams of silver metal during the lab. However, your calculations indicate that you should have only produced 0.75 grams. If you should have produced 0.75 grams, what was your group's percent error? So your value, what your group actually produced, is 0.85 grams. You're going to subtract that from the actual value, the true value, 0.75. And then divide that, once again, by the true value, what you should have produced. And then multiply by 100. So we get 0.85 minus 0.75 is 0.1. 0.1 divided by 0.75 is 0.13333. Times that by 100, and we get your group's percent error was 13.33%. Alright, so that's how you do percent error analysis. Another type of calculation, part 6, converting between mass of a substance to moles of a substance. So in the packet, I got a little crazy triangle here. Sorry about that. We had the red triangle on the front board so that we could keep our calculations straight. So mass is how much you have of something. The molar mass is how much a mole of something weighs, which we just calculated in questions 5 through 8 using the periodic table. And moles. So these three things are related like so. So whatever you're trying to solve for, you cover up. And so in these problems, we're trying to solve for moles. So we're going to cover up moles. And if we cover up moles, we're solving for moles, we get that the number of moles of a substance is equal to the mass in grams. So if you had this stuff sitting on a scale in front of you, how many grams would it weigh? Divided by the molar mass, how much 602 sextillion is something weigh? Alright, so we're going to use this formula to solve for 11 through 13. So let's go ahead and do that. Question 11. If you have 35 grams of aluminum, how many moles of aluminum do we have? The mass is how much we have divided by the molar mass. We look at the periodic table. Aluminum weighs 26.98 grams per mole. Take our mass, we divide it by the molar mass, and we have our number of moles. So we have more than a mole because we have 8 more grams than what a mole weighs. So we know our number is going to be bigger than 1. So we go ahead and calculate this, and we find out that we have 1.3 moles of aluminum. Take a look at question 12. Question 12, we have a 100-gram gold statue. So if we have 100 grams of gold, if we have 100 grams of gold, that's our mass. To figure out moles, we got to divide it by the molar mass. We look at the periodic table. Gold weighs 196.97 grams per mole. 100 divided by that equals less than a mole because we have less than 196. And so you should have calculated 0.51 moles. Alright, 13. Number 13, last one here. Mr. Lehman has 4.4 grams of gold in his wedding ring. How many moles of gold metal are in his wedding ring? So once again, my mass, 4.4 grams of gold divided by how much a mole weighs. Calculate this. We definitely have way less than a mole. We have 0.022 moles of gold in Mr. Lehman's ring. And that's a real calculation there. For extra credit, how much would that be worth? Did Mr. Lehman get ripped off? Alright, so that's part 5 and part 6. Part 5 and part 6. So this ends the third part of the tutorial. There is one more section left, so I encourage you to check that out as well. Thanks and have a great day.